All right, welcome to The Explainer. Today we're going to dig into a really fascinating agricultural puzzle, and it all starts with something that, honestly, just looks plain weird.
I mean, just look at them. They're baby onions, perfectly healthy and growing, so why on earth would farmers chop their leaves off? It seems completely backward, kind of like trimming the sails on a boat when you want to go faster. But believe it or not, this common practice is a crucial first step in modern, large-scale onion farming.
So to really get why they do this, we've got to first understand the problems that pop up when you're trying to grow literally thousands and thousands of these things for machine planting. Picture a greenhouse, just packed with these trays. Now, to get the most out of the space, these seedlings are grown incredibly close together. And that high-density environment, plus all the water they get, creates this perfect storm for a problem they call overgrowth. Basically, the seedlings just shoot straight up, getting all tall and spindly.
So you end up with two types of seedlings. You've got the overgrown ones, tall, skinny, and they get all tangled together. A total nightmare for a machine. And then you've got the ideal seedling. Short, tough, and perfectly uniform. That's the one the automated planters can actually handle.
Okay, so the solution to that overgrowth problem is, you guessed it, that haircut we saw earlier. But, and this is a big but, it turns out this simple fix creates a whole new and maybe even more dangerous set of problems. You know, for the longest time, everyone just assumed that trimming was like a workout for the plant. You know, good stress that would make the base stronger. But when scientists actually put it to the test, whoa, they found the complete opposite was happening. Instead of making the seedlings tougher, cutting was actually making them weaker.
And this all comes down to a key measurement called the bulb neck diameter. It's just what it sounds like, how thick the seedling stem is at the base. Think of it like the plant's little ankle. And the research was crystal clear. The more you trim an onion seedling, the thinner and weaker that crucial part of the plant gets.
And oh, it gets worse. Every single cut is an open wound, right? So that opens the door for nasty diseases like leaf blight. It also makes the whole plant less sturdy, what scientists call a lower dry matter rate. So this all leads to this massive question. Is this necessary evil actually destroying the final crop? Okay, so to finally get some real answers, scientists in Korea designed this really smart experiment. They wanted to figure out where that sweet spot is, the perfect balance between trimming for the machines and keeping the seedlings healthy. So here's the setup. It was pretty clever. They took a bunch of seedlings and split them into groups. One group was the control, no cuts at all. Then they had groups that got 1 trim, 2 trims, or even 3 trims. But here's the kicker. For every group that got a trim, they split it again. Half got a fungicide treatment right after, and the other half got nothing. This way, they could see exactly what was causing the harm, the cut or the infection that followed. And the first results, well, they were pretty much what you'd expect. The more you cut, the shorter the seedling. The uncut ones grew to about 25 centimeters, but the ones trimmed 3 times, they were tiny, barely 10 centimeters tall. So yeah, no doubt about it, trimming stunts them and makes them weaker. But, and this is where the story gets really interesting, the researchers figured out that the cut itself wasn't the real villain here. The actual danger was that open wound and the leaf blight disease that was sneaking in. And that was something they could actually control. And bam, here's the proof. Just look at this. The seedlings that were cut but got no fungicide, they had disease lesions over 7 millimeters long. But the ones that got the fungicide right after trimming, the damage was cut almost in half, down to just over 4 millimeters. This was the game changer. All right, so let's recap. We know that trimmed seedlings are shorter, they're weaker, and they need medicine to fend off disease. So that's got to mean you end up with smaller onions at harvest time, right? Well, maybe not. I mean, this was the big one, the million-dollar question. Does all that early stress mean you get a worse harvest in the end? This is what the farmers really needed to know. And the answer was a huge, resounding no. It's totally counterintuitive. But the study showed that all that early weakness, it made absolutely zero difference to the final onion. The numbers don't lie. Check this out. The onions that came from those big, healthy, uncut seedlings, they weighed in around 255 grams. And the onions from the little seedlings that were trimmed 3 times, they were around 242 grams. And while that sounds like a bit of a drop, statistically speaking, it's identical. There was no real difference in the final weight. So here's the big takeaway. As long as you protect those little seedlings from disease right after you cut them, they bounce back completely once they're in the field. This is huge. It means farmers can go ahead and trim as much as they need to for their machines, and they don't have to worry that they're hurting their final yield. So what does all this mean for the farmers on the ground? Well, it basically gives them a brand new, science-backed rulebook to follow.
It really boils down to this simple protocol. 1. Go ahead and trim the seedlings 2 or 3 times to keep them ready for the machinery. 2. Do it in the morning. This gives the cuts time to start healing during the day. And 3. This is the most important part. Right after every single cut, apply that protective fungicide to stop disease in its tracks. You do that, and you're set for a full, healthy harvest.
And that's really the power of a study like this. It starts with a simple question about what looks like a weird haircut for an onion, and it ends with a powerful, proven system for more reliable, more productive farming. It's a perfect example of working smarter.
It really makes you think, though, doesn't it? You have to wonder what other common-sense farming practices out there are just based on old assumptions that nobody's ever really put to the test. What other secrets are just hiding out there in the fields, waiting for someone to ask the right questions?